Hi all, welcome back. So today we are going to solve all the questions from area under the curves which came in different shifts of Jan 2025 attempt. In area under the curves we have total 12 questions, out of which 6 are easily doable, 5 are moderate and 1 is easy but lengthy, which we are going to solve. And this difficulty level is basis my perception, which may be different for others. So let's begin with our first question. Here is our first question now. Our question says the area of the region enclosed by the curves, this curve and this curve is. So in this question we need to find the area between these two curves. So first of all, let's write these two curves. We can write the first curve as y is equal to x minus 2 whole square, comma. We can write the other curve as y square is equal to minus 8 multiplied by x minus 2. Now let's plot these two graphs. Here is our coordinate axis. Let's say this is our point. Here we have our point 2. So this curve will be y is equal to x minus 2 whole square, and here we have our other curve. So this curve is y square is equal to minus 8 multiplied by x minus 2. So here our required region is this region. We need to find the area of this region. So there is a shortcut. There is a shortcut to solve these type of problems. So suppose we have two parabolas. Let's say one is y square is equal to 4ax, and the other parabola is x square is equal to 4b y. So here we have our region here is our region which we need to find the area of. So our area of the required region is equal to, in this case, 16ab upon 3. So we are going to use the same formula here in this question. So our area is equal to 16 into, in this equation a will be 1 upon 4, and in this a b will be 2 divided by 3. So this is equal to 16 by 2, 8 upon 3. So our answer is option A. From here we can see that our answer is correct. Here is our next question now. Our question says the area of the region bounded by the curves this and this is. So again in this question we need to find the area bounded by these two curves. So first of all we will make a rough sketch of these two curves. So this is our coordinate axis and this will be our parabola. Y square is equal to 2x. Now first of all let's find the intersection points of these two curves. So this will be x multiplied by 1 plus 2x is equal to 1. From here we will get 2x square minus 1 is equal to 0. From here we will get x is equal to 1 upon 2 comma minus 1. Yes. Now here our minus 1 upon 2. Here our minus 1 will get rejected. Our minus 1 will get rejected and 1 upon 2 will get accepted, because when we will take x is equal to minus 1 in this parabola, we cannot find any real values of y. So from here our curve of x multiplied by 1 plus y square is equal to 1 will be of something this type. So from here two intersection points will be 1 upon 2 comma. When we will put 1 upon 2 in this parabola, we will get y is equal to plus minus 1. In the first quadrant plus 1, and in the fourth quadrant 1 upon 2 comma minus 1. This is y-axis and this is x-axis. So our required area is this region. This is our required area which we need to calculate. So our area is equal to, we will calculate the area with respect to the y-axis. So from here our area will be integral from minus 1 to 1, 1 upon 1 plus y square minus y square upon 2 dy. So this is equal to tan inverse y minus y cube by 6 from minus 1 to 1. From here this is equal to, when we will put 1, we will get pi by 4 minus 1 by 6. And when we will put minus 1, we will get minus pi by 4 plus 1 by 6. So this is equal to pi by 2 minus 1 by 3. So from here our option B is correct, and here is the solution, and we can see that our option B is correct. Here is our next question now. Our question is, let the area enclosed between these two curves, this and this, be alpha, and 9 times alpha is equal to beta pi plus gamma, where beta comma gamma are integers. Then the value of beta minus gamma equals. So in this question we basically need to find the area enclosed between these two curves. Then we need to just compare the values. So first of all we will draw these two curves. These are our coordinate axes. This is a circle. More bigger. Yes. So let's say this is our circle, x square plus y square is equal to 1. And here we have modulus of y is equal to 1 minus x square. So graph of this will be like this, and this. So from here our required area of the region which we need to calculate is this region. So we need to calculate the area of the shaded region. This is y-axis, this is x-axis. Now our area of, well, here we don't need to find the intersection points. We can clearly see it through the symmetry. This will be 1 comma 0 and this will be 0 comma 1. Now our required area is equal to area of the whole circle. Area of the whole circle is pi r square. So in this case our r square is 1. So pi r square will be pi minus 4 times the area of this region. So 4 times area of this region will be integral from 0 to 1 of 1 minus x square, yes, 1 minus x square dx. So from here we will get this is equal to pi minus 4 times x minus x cube upon 3 from 0 to 1. So from here this is equal to pi minus 8 by 3 and this is equal to alpha, so 9 alpha is equal to 3 pi minus 24. From here on comparing, beta is equal to 3, gamma is equal to minus 24, gamma is equal to minus 24. Please wait a minute. So here our beta will be 9 because we multiplied both sides by 9. 9 pi and again here this is equal to 9. So from here our modulus of beta minus gamma is equal to 33. From here our option B is correct and here is our solution and we can see that our answer is correct. Here is our next question now. Our question says the area of the region enclosed by the curves, this curve and this curve and the y-axis is. So in this question we need to find the area between these two curves and the y-axis. So first of all let's plot these two curves on the coordinate axis. This is y is equal to e raised to power x. This is 1 comma 0, 1 comma 0 and y is equal to modulus of ex minus 1 will be this and this. Yes. All this stuff. Let's make it a little wider. Yes. Now, here our required area of the region, this is y-axis, this is x-axis. So the required region is this region. This is y is equal to modulus of e raised to power x minus 1. Now, we need to find the area of this required region. So our required area, first let's find the intersection point. Ex, e raised to power x is equal to 1 minus e raised to power x, 1 minus e raised to power x, and from here we will get ex is equal to 1 upon 2. So x is equal to ln of 1 upon 2. So our required area of the region is integral from, we can write ln 1 upon 2 as minus ln 2 to 0 e raised to power x minus 1 minus e raised to power x dx. So from here this will be 2 times e raised to power x, 2 times e raised to power x minus x, from minus ln 2 to 0. So we will get 2 minus 2 minus 1 minus ln 2, 1 plus ln 2. So from here this is equal to 1 minus ln 2. So from here our option A is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. So our question says let f r to r be a twice differentiable function, such that here we have our functional equation for all x comma y belongs to r if f dash 0 is equal to 4a and f satisfies this equation, then if a is greater than 0, then area of the region R is equal to y. Now here in this question, we have given a functional equation and a result. So from here we can find f of x. Then from the second part we can easily find the area of the region. So if our functional equations looks like this, f of x plus y is equal to f of x into f of y, we can assume our f of x as p raised to power x. So from here f dash 0 is equal to p raised to power 0 ln p is equal to 4a. So from here p is equal to e raised to power 4a. From here our f of x is equal to e raised to power 4ax. So from here our f double dash of x will be 16a square e raised to power 4ax minus of 12a square e raised to power 4ax minus of e raised to power 4ax is equal to 1. Please wait a minute. 16 minus 12 is equal to 0. So from here our e raised to power 4ax will get cancelled. We will take it to the right hand side. So from here we will get 4a square is equal to 1. So our a is equal to 1 upon 2 or minus 1 upon 2. Now here our minus 1 upon 2 will get rejected and 1 upon 2 will get accepted because our a is greater than 0 as given here. So our f of x is equal to e raised to power 2x and f of ax is equal to e raised to power 2ax, so e raised to power x. And here is our graph of e raised to power x. Y is equal to e raised to power x. Here we have 0 and here we have 2. So this is our required required area which we need to find. So from here our area of the region is equal to integral from 0 to 2 e raised to power x dx. So from here this is equal to e square minus 1. So our option A is correct, and here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, if the area of the region, here is our region, is this, then the value of A is. So we need to find the area of this given region and compare it to this value, then we can find the value of A. So first of all we will write y. Our y is equal to A plus e raised to power x minus of e raised to power minus x, and if this is when our x is greater than 0. If our x is less than 0, we will get e raised to power minus x minus of e raised to power minus x. So these two will get cancelled and we will be left by A. So from here we can make the graph of our y. So this will be when x is less than 0, so this will be A. And when x is greater than equal to 0, this will be A plus e raised to power x minus of e raised to power x. For this point, this is y is equal to A, and at this point, or wait a minute, this whole line extended is y is equal to A. Now we need to find the region from minus 1 to 1. Please do not consider this line, so let me remove it. So we need to find the area of this region. So first of all, this is y-axis and this is x-axis. In the left of y-axis, this distance is 1 and this distance is a, because this line is y is equal to a. So from here our area is equal to, for the left side of y-axis it will be a, plus for the right side it will be integral from 0 to 1 a plus e raised to power x minus e raised to power minus x dx. So this is equal to a plus ax plus e raised to power x plus e raised to power minus x from 0 to 1. So from here this is equal to 2a plus e plus 1 upon e, and plus 2 is equal to, from here we will get e, we can write this as e plus 1 upon e plus, wait a minute, this will be minus 2. Yes, this will be e plus 1 upon e plus 8. From here e plus 1 upon e plus 1 upon e will get cancelled. So 2a minus 2 is equal to 8. So our a is equal to 5. From here our option C is correct, and here is our solution, and we can see that our answer is correct. our next question now. Our question says, if the area of the larger portion bounded between these two curves is this expression where b comma c belongs to n, then b plus c is equal to. So here we have two curves, we need to find the area between them, and then we will compare it to find the values of b and c. So first of all, let's make a rough diagram. Here are our coordinate axes. Let's say this is our circle. And this is point 1. So this is our graph of y is equal to modulus of x minus 1. So here we need to find the area of this region. This whole region. I am not highlighting it because here is one more thing, then we will highlight it. So first of all, we will take y is equal to mod of x minus 1 here. We will get x square plus x square minus x square minus 2x plus 1 is equal to 25. From here we will get x square minus x minus 12 is equal to 0. So our x is equal to minus 3 comma 4. So this point will be minus 3 and this point will be at 4. So to find the area of the larger region, our required area is equal to pi r square. R square is 25. So pi r square will be 25 pi minus integral from minus 3 to 4. Minus 3 to 4, 25 minus x square under root of 25 minus x square. From minus 3 to 4, then we have subtracted these two right angle triangles. We will look at, here we have our two right angle triangles. When we subtract this area, we also subtract these two right angle triangles. So we need to add them up. So this will be plus 1 upon 2. This is minus 3. At minus 3, this will be 4. And at x is equal to 4, it will be 3. So from here we will get 1 upon 2 into 4 into 4 plus 1 upon 2 into 3 into 3. So this is equal to 25 pi. 16 plus 9, 25 by 2 minus integral of under root of 25 minus x square will be x upon 2 under root of 25 minus x square plus 25 upon 2 sine inverse x upon 5 from minus 3 to 4. So this is equal to 25 pi plus 25 by 2 minus, when we will put 4, we will get 25 minus 69, 2 times 3, 6. 6 plus, here we will take 25 upon 2 common. In the addition we will get sine inverse 4 by 5 plus sine inverse 3 by 5. And when we will put 25 minus 9, 16, 8, 16, 4, 2 times 3, it will be positive 6. Minus of minus 6, positive 6. So from here 25, this is equal to 25 pi plus 25 by 2 minus 6 plus 6, which is 12, will be 1 upon 2. And our sine inverse 3 by 5, we can write it as cos inverse 4 by 5. So from here sine inverse 4 by 5 plus cos inverse 4 by 5 will be pi by 2. So this is minus 25 upon 2 into pi upon 2. From here we will get, this is equal to 4 times minus 4 times 25, 3 times 25, so 75 pi 1 upon 4, 75 pi plus 2. So from here, on comparing this result and the given result in the question, we will get B is equal to 75 and C is equal to 2. So from here our B plus C is equal to 77. So our answer is equal to 77. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says the area of this region is equal to. So we need to calculate area between these two curves. So here we will only plot the x-axis. We will only plot the x-axis, we will not plot our y-axis. So x square plus 4x plus 2 will be a curved parabola. It will have two roots. So it would be like this. And y is equal to modulus of x plus 2. It will be like this. At minus 2. Now, here we need to find the area of this region. So let's compare x square when our x is greater than minus 2. X is greater than minus 2. Minus 2 we will get x square plus 4x plus 2 is equal to x plus 2. So x square plus 3x is equal to 0. Our x is greater than equal to minus 2. So following these, our x is equal to 0. The other root will get rejected. And when x is less than minus 2, we will get x square plus 4x plus 2 is equal to minus x minus 2. So we will get x square plus 5x plus 4 is equal to 0. So from here our x is equal to minus 4. The other root will get rejected because the root will not satisfy the condition. So from here this is at minus 4 and this is at 2. This is at -4 and this is at 0. At x is equal to 0, this will be 2, and at x is equal to -4, again it will be 2. So these 2 points are in one line, and the line is y is equal to 2. So our area of the whole region, our area of the required region is equal to integral from -4 to 0, y is equal to 2, the line, minus the parabola x square plus 4x plus 2 dx minus the area of this triangle. So area of this triangle is 4 minus 1 upon 2 into 4 into 2. So this is equal to minus x cube by 3 and minus 2x square. Yes, minus 2x square from -4 to 0 minus of 4. When we will put -4, we will get 64 upon 3 and minus 32 minus 4. So 3 times 36 will be 8. 1, 9. Please wait a minute. This is minus 64 upon 3 plus 32 minus 4. Yes. So we will get 28 times 3. 4, 284. So this is equal to 20 upon 3. From here, our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, consider the region R. Here we have our region. The area of the largest rectangle of sides parallel to the coordinate axis and inscribed in R is. So here in this question we need to use a little bit of AOD, applications of derivative also, to solve this question. So first of all, let's plot our graph. So here is our graph. Now it intersects y-axis at when y is x is 0, so at 0, 9, and it intersects x-axis on the positive side. This is x-axis, this is y-axis. At root 27, wait a minute please, 9 times area of the largest rectangle. Y will be 0, so 327 upon 11 under root of 27 upon 11 comma 0. 20, let me recheck it. 9, yes. So here we have a square, x is greater than equal to 0. So here we have our rectangle, which the sides of the rectangle are parallel to the coordinate axis and inscribed in R. So the area of largest inscribed in the region R. Yes. So here also we have a line, sorry. Here also we have a line. Y is equal to x, and here is our rectangle. Now let's say this point is x comma x, x comma x. So the area, we have to find the area of this rectangle. So our area is equal to x into 9 minus 11 upon 3x square minus x, because the y coordinate of this point, this is vertical, so it will be 9 minus 11 upon 3x square, so this distance will be this. So from here we will take the first derivative of the area. We will get 9 minus 11x square minus 2x is equal to 0. So from here our x is equal to minus 1 comma 9 upon 11. So our d2a by dx square is equal to minus 2 minus 22x. So from here, when we will take x is equal to 9 upon 11, our d2a by dx square is less than 0. So this means that x is equal to 9 upon 11 is point of maxima. Then from here our x is equal to 9 upon 11. Now from here our area, inscribe area of the required region. Please wait a minute. Area of the largest rectangle is equal to 9 upon 11. 9 minus 11 upon 3 into 9 upon 11 into 9 upon 11 minus of 9 upon 11. So 11 will get cancelled, 3 will cancel 9 3 times. So from here this is equal to 9 minus 36 upon 11 into 9 by 11. So this is equal to 99 minus 36, 63 into 9 upon 11. So from here this is equal to 567 upon, this is 11 into 11 upon 121. So from here our option, let me check this, our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says the area in square units of this region is. So we need to find the area of the region of between these three curves. So first of all, let's plot these three curves. So this is our y is equal to x square plus 1, and this is y is equal to 2 magnitude of x plus 1, and mod of x is equal to 3. This is 3, and this will be minus 3. Minus 3. Now let's find the roots of these two intersection of these two curves. So x square plus 1 is equal to 2x plus 1. So x is equal to 0 comma 2. Other is x square plus 1 is equal to minus 2x plus 1. From here x is equal to 0 comma minus 2. From here this is at minus 2 and this is at 2. This is at minus of 2. Now our area of the required region is this region. So our area is equal to 2 times integral from 0 to 2 x square plus 1 dx, and then we have this trapezium. So this point will be 3 comma 7, this point will be 2 comma 5, 2 comma 5. So from here our area of trapezium will be 1 upon 2 sum of parallel sides into height 1 into distance between parallel sides 1. So from here this is equal to 2 multiplied by this will be x cube by 3 plus x from 0 to 2 plus 6. From here this is equal to 2 times 8 by 3 plus 2 for 14 by 3 plus 6. So from here this is equal to 64 by 3. So our answer is option B. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let the area of this region be A, then 6 times A is equal to. So here we need to find the area between these three curves. So first of all, let's plot these three curves. So this is our y plus mod of x is equal to 3 at 0 comma 3, and this is y is equal to modulus of x minus 1 and the other equation 2y less than equal to x square plus 3, this will be of this type. So from here this is our equation 2y is equal to x square plus 3. Now our area of these three curves. So our required region is this area. So first of all, let's find intersection points of y plus mod x is equal to 3 and y is equal to mod of x minus 1. So we will get 3 minus x is equal to x minus 1. So x is equal to 2. And the other is x minus 3 plus x. 3 plus x is equal to 1 minus x. We will get x is equal to minus 1. So this point will be 2 comma 1, and this point will be minus 1 comma 2, and this point is 1 comma 0. If this is minus 1 comma 2, so this point will be 1 comma 2. Let me check it. 4, yes. So now our required area is equal to, first of all we will find the area of this rectangle. Now these all the edges are perpendicular, so this is the rectangle. From here our area will be root 2 into 2 root 2 minus area of this sector. This is looking like a sector, so that's why. So area of this region, unwanted region, will be minus of 2 times integral from 0 to 1 3 minus x minus of x square plus 3 upon 2 dx. So this is equal to 4 minus 2 times 3x minus x square by 2 minus x cube by 6 and minus 3 by 2x from 0 to 1. So this is equal to 4 minus, this is actually a 4 minus 2 times 3 minus 1 upon 2 minus 1 upon 6 minus 3 upon 2. From here this will be minus 4 upon 2 minus 2 1 5 4 minus 5 upon 3. So this is equal to, so this will be 7 upon 3. From here our 6a is equal to 40. So our answer is option C. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says the area of the region inside this circle and outside this parabola is. So we need to find the area inside the circle and outside the parabola. So first of all, let's plot it. Here is our circle, and this will be our parabola. this circle passes through the center. And this will be our parabola. So the required area which we need is this yellow shaded region. Now let's find the intersection point of these two curves. So this will be x square minus 4 root 3 x plus 12 plus 2 root 3 x is equal to 12. So from here our x is equal to 0, 2 root 3. So this point lands at the center 2 root 3, 0. So from here our required area is equal to 2 times 1 upon 4 into pi r square, which is 12 pi minus the unwanted area, integral from 0 to 2 root 3 of under root of 2 root 3 x dx. So this is equal to 2 multiplied by 3 pi minus under root of 2 root 3. Inside we will get x raised to power 3 by 2 upon 3 by 2 from 0 to 2 root 3. So we will get 2 root 3 raised to power 3 by 2 plus 1 by 2. So 2 root 3 whole square. This is equal to 2 multiplied by 3 pi minus 2 root 3 whole square, which is 12. Wait a minute please. Here I am making some mistake. Yes, this is divided by 3 upon 2. So 12 into 2 upon 3 will be 4. So this is equal to 6 pi minus, 12 into 2 upon 3 will be 8. 6 pi minus 16. So from here our option B is correct. And here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.